So this example here requires us to find the effective value for the waveform that we see here, right? So effective value, which we know to be the same as RMS value, right? So that's RMS value. And we know the R here basically stands for root, right? I mean, within the formula we use as a square root. The mean here just say that we divide it by the period, which is t, right? We divide everything we have by the period. There's some division by period. And then the S here basically means the squared, right? The squared area, right? Squared area. This basically for us to remember what we are doing. But the formula itself, for us to need to find the RMS, we know that to be, right? So the RMS value is the square root, right? And then we have the squared area, area squared, right? And then we have the period, which is the t, right? So this is basically what gives us the the RMS value or the effective value, right? So looking at this shape here, we can see actually see that there are three figures, right? But in order for us to do what we have to be able to first find the period, right? And then find the squared area and put everything under this, or this in this case the sum of the squared area because the areas are three, right? And then we'll be able to find the RMS value, right? So the easiest to do now is for us to find the period. So let's see. So the waveform starts like this, goes up, stays horizontal, comes down this way. But this is one thing for you to be able to find the period, right? So let's see. When we are finding the period, you see it starts this way, right? So where it starts should be where it ends. So like where it's starting, whenever the next cycle is starting, it should start the same way, right? And then it should start in the same direction. So let's see how this goes, right? So you see, when the cycle started, it started at the origin where here is 0, right? So that's it. So that's one thing. Any other point that starts, so this one here starts at 0, this one here starts at 0, this one here starts at 0. But which of them will have this slant here? That's what will tell you where the period ends, where the cycle ends, right? So the one that goes in the same direction is here, right? So what this tells us is that the period or the cycle ends at that side, right? So let's see. So clearly, it's the only one that starts at the same point and then have the same kind of like directional slope, right? So this is where this says that this is where the first cycle ends and this is where another cycle begins. So this is what we get from that, right? So clearly we know that the t that we are looking for here is equal to 12 seconds, right? So the next thing for us to find the area, right? Okay. And then because we are doing RMS, let's pay attention. We know that RMS uses squared area, right? So the squared area means that you square the area under this graph, right? So if we are talking about this side, you square the area under the triangle, right? So what that will be is that the base of the triangle remains the same, but the height stretches, goes up something like this, right? So something like that. This is just for illustration. Right. So the base remains the same, but the height stretches. Right. So this is how the squared area will be. The same for this triangle here. So this is one, this is two. What happens to this one is that it goes up, right? Something like this, right? And here, you see, it has a what do you call it? The height is negative, but when you square it, the base is the same, but it comes here squared, right? So it will be about 4 here, somewhere like this. Right? So, but then you do not know. It's not straight for you to know all this, right? You just have to know the formulas, right? So we've broken down the formulas and then we see how it is. So we're just going to use the formulas and then we punch everything and we get what we are looking for, right? So let's see. There's a summary. When we have a triangle, when we have a square, right, or let's say a rectangle, right, the area under that graph or waveform like this, right, as in this case, right, or in this case, right, the area under it is basically just the area, not the square area, just base times height. When it comes to square area, the base remains the same, right? The base remains the same, the height is squared. So right, this one changed from 1 to 2 here, as we see, right? But when it comes to a triangle, the area, normal area, is just half times base times height, right? But the squared area, right, is 1 on 3, right, times base times height squared. So the only thing that's changing is that this 2 here is changing to 3, and then this one exponent here is changing to 2 exponent here. So when you have these formulas in mind, you'll be able to work with them. And there's a particular formula too for the normal sine wave, right? I think we've seen that already. Okay, so we are going to go straight into it. So we know what we need to do already. We know the formula, right? The formula is square root, and we have this, and then the period at the bottom. We know the period now to be 12, right? And now here, because we have more than one shape, complex shape, we have three shapes here. So we just we have to find the square area under each, right? So that means adding three things, so this plus, right? If you know what to do, you can just punch everything and go straight for it, right? So for the first part, one is a triangle, right? So that one, if you find the square, because you find RMS, if you find the square area under it, it's 1 on 3, right? Times base. The base is 4. There's a base. So the base is 4 minus 0, which is 4 base, right? We are using this formula here. So now we are using this here. Oh, we are doing for the triangle. So we are using this here. 1 on 3 times b is 4, and the height is 8 minus 0 is 8, right? So times 8. So let's put this in bracket to make things clearer. Right. Okay, we go to the next one, which is the area 2, this side, right? It's a rectangle. To have the same formula as this. So that will be base times height squared. The base is what? Let's do this so it's clearer. Okay. Okay. So the base here. Okay. So the base here is 8 minus 4, right? So we are using this formula. It's because it's a rectangle. Base times height squared. So the base is 8 minus 4. That's 4, right? And the height is this 8 minus 0, right? So that's 8 minus 0. That's 8. And then for the formula here, we are squaring it, right? Square. And then we go to the third part, which is this, right? It's still kind of like a square rectangle, so we use this formula, right? We are still on this formula here. All right, so the base is what? So we have here, so let's pay attention to this. So we know here is 10, sorry, here is 12, here is 10, so definitely the in between there will be 11, right? So 11, right, minus 8, so that gives us 3, right? That's the base, and the height is from here to here, which is basically minus 2, times minus, so let's put in brackets, minus 2, we square that, right? Minus 2, minus 2, and then we square that, right? So let's see. So here, let's look at the formula again. I think we missed something. Yeah. So for the triangle, which is the first part, we have 1 on 3, right? That's here. Base times height squared, right? Squared. And then for the second part, rectangle, we have, so this is the formula, base times height squared, base times height squared. And then for the third part, we have base times height, which is minus 2, right? And when we square that, yes, it's still 4. So that's what we have. So basically, we end up with the RMS. So this means that when you are doing anything, you know the formula to use and you understand the concept, you can go straight for it, right? So we end up having the RMS value for this waveform here to be 5.42, let's do 4 dB, 63 volts, right? Because it's actually a volts, what do you call it? Yeah, a voltage waveform, right? So that's what we have for it. All right.